Now, last method for forecasting is decomposition. This method is used when you have data with a trend, seasonality, and random variations all together. So this is most complex method among the ones that we have learned and covered so far. When both trend and seasonal components are present in time series, the forecasting model selected must address this issue. The decomposition method, which uses seasonal indices, is a very common approach. Multiple regression models are also common, with dummy variables used to adjust for seasonal variations in an additive time series model. The process of isolating linear trend and seasonal factors to develop more accurate forecasts is called decomposition. These are 5 steps to follow. First one is compute seasonal indices using centered moving averages. Second, de-seasonalize the data by dividing each number by each seasonal index. Step 3, find the equation of a trend line using the deseasonalized data. Step 4, forecast for future periods using the trend line. Step 5, multiply the trend line forecast by the appropriate seasonal index. So these 5 steps we have to follow and then calculate everything together. The first step was already done from the previous slide, so we don't have to necessarily go for. But if I may do it again, here's the sales data, and if you want to find the CMA, then you start with the quarter three, and you add them up and divide it by that. So 125, 150, 141 are included, and 50% of 108 and 50% of 116. You add them up and divide by 4. That is going to create your CMAs. So you can create them all together there. And the second step is deseasonalize the data. So we calculate using that, we calculated the seasonal index with a trend, and we found that in quarter one there was 0.85. So we put 0.85 over there, and for quarter two, 0.96. So 0.96 here, 1.13 is over there, and 141 is there, 1.06, 1.06, and 0.06. That's created there. So seasonal index is created, inserted there. That just deseasonalize the data. And to do that, now what you do is you um, divide your quarterly sales data by this seasonal index. So 108 divided by 0.85 gives you 127. 125 divided by 0.96 gives you 130, and so forth. So you are able to create deseasonalized sales data in step 2. In step 3, you have to find the equation of a trend line using the deseasonalized data. So now we are going to use the linear regression or Excel to find these values. And then if you find them, then forecast for future periods using the trend line. For example, say you have y equals a plus bx, and you found that trend line, then for the next quarter, you can insert that number and find the future forecast for yourself. And number 5 is multiply the trend line forecast by the appropriate seasonalized index. So that's the last step that we need to follow. So decisionalizing, I told you, so I'm going to move on to the next slide. So let's find the trend line, and in this case, if you use Excel, you can easily find the slope and the intercept, and that is given as 2.34 and 124.78. So now you have y hat equals 124.78 plus 2.34x, and say you want to find the first quarter after 3 years that forecast, then you just need to enter 13 there. So 124.78 plus 2.34 times 13 gives you 155.2. So that's your forecasted sales at quarter one of year four is given right there. And in step four, forecast for future periods using the trend line. Um, we have to develop a forecast for quarter one, year four that we have done, and that's created right here. So that's created, and we can, just look at the graph. This is a decisionalized data, and the trend line would just go right in between the decisionalized data, and you see it's much more stable than the other actual sales data because you decisionalized it. And step five is multiply the trend line forecast by the appropriate seasonal index. So seasonal index, we already calculated 0.85, 0.96, and 1.13 and 1.06. And for year four, 1, 2, 3, 4, we are able to um, estimate the forecast by entering 13 year and 14, then 157, 16, 159, 17, 162.22. Then you have this forecast, and then you multiply this one by this seasonal index that we calculated from the previous slides, and then we have here, right? So final or just forecast because we apply the seasonal index, then 155.20 times 1.85 produces 131.92, and similarly 157.54 times 0.96 gives 151.24, and so forth. And you are able to have this final adjusted forecast using that formula. Then your projection will look like this. And then your adjusted finally adjusted forecast is right here. It has some seasonality because you applied your seasonal index there. This is projected sales, and then here is adjusted forecast. So this is how you can calculate or do forecasting with trend, seasonal, and random variation. It's a little bit more complicated, but it produces more accurate forecast for you. And this is a decomposition method. Thank you.